to control the movement of an electron. So that is a tricky one. But once you have that kind of creation, so it's very easy for us to control control in any dimensionality. So once you have such system, we call them as a quantum dot, which is like less than 5 nanometer in size. So these two like typically covers the properties of nanomaterials. So talking on the preparational aspect, so we have seen two important properties. One is the surface to volume ratio, and second as your quantum confinement. So creation of such objects, it's again it's a little tricky one. So there are two different approaches where people use it for creation of nanomaterials. So one is your top-down approach, and second is your bottom-up approach. So bottom-up approach is it's something like, so we start from atoms. So we start from a smaller thing and we make them cluster with certain chemical reactions, and then we make it as a nanostructures, which I have put over here. So we start from atoms and then we do some chemical reactions and then we make it as a clusters, and then we process it further to make nanostructures. So this process everything will be seeing in the next slides. So top down is the one like where we take any bulk system and we do some kind of physical processes and we make them and we bring them down in their structure. So there we have some kind of nanostructures. So like each one have their own advantage. Like bottom up is the one where it does not involve any sophisticated instruments or no laboratory. I mean no like larger lab space. Something like that. So such kind of things are not needed when you work on these bottom up approaches. But when you go for top down approaches, we need we need a higher lab setups, and we need to the purity of the system matters. So we need to have some kind of clean rooms, and all that things comes into play when you work on this top down approach. So each one has their own potential and each one has their own applications. So based on the application of our interest, we can select which one to use. But we'll be discussing like what are the process that can be used in terms of bottom up approaches and in top down approaches one by one. But ultimately like it is up to our hand, like which process we have to take for the creation of nanomaterials. It's up to us. So based on the requirement and based on the application what we prefer, so we can go for the preparation process. So we'll start with I mean there are two, I mean I have put some some categories of methods which can be used for the preparation. So top down approach is when as we seen that we take the bulk system and then we break down and then we bring into a smaller scale. But the thing is that we'll have one kind of disadvantages is that like it leads to a damages. Like if you take some bulk silicon wafer and then we do some process it, and then if you try to bring it to a lower scale, so there is a chances for the system or the crystal to get break. There is a one disadvantages. So this break or these changes in the crystal system can have greater impact on your properties. So that is what I put over here. Like it leads to a crystal damage, and then it leads to a surface imperfections. But whereas in case of bottom up approach is nothing. Just we have a some beaker system, and we do mix some chemicals, and then we do it in some heat treatment and some simple process we do, and then like we get some nano-sized nanoparticles. So like it does not involve any hazardous chemicals. It does not involve. And another way is that like you have this crystallinity aspect will be maintained. In addition to that, we can greatly alter the chemical composition. Like rather going for a single composition, we can go for dope system or like binary, trinary, ternary group, and all that thing can be brought in. So like so I'll say like it's better to for a beginner to start with these bottom-up approaches. It's very simple. So just mixing of two chemicals and applying some kind of external environment. So that is the thing. So that is what I put over here. And if you listed the approaches, like top-down comes under your top-down approaches comes all your lithography techniques, and the ball milling comes that comes under your top-down approaches. In case of bottom-up approaches, again you have certain physical and chemical methods, so which we'll see one by one. So bottom-up approaches. So we'll start with the chemical methods. So there are I've listed few chemical methods. Like one is solvothermal reaction, and second is your hydrothermal reactions, and third is your microwave synthesis, and fourth is for salt gel method, and fifth is for chemical reaction, and sixth is for green synthesis. So the complete physics and chemistry will be discussed, so kindly bear with me. So what is chemical synthesis? It's very simple. So we have some kind of initial material or precursor material, we can say, and we mix it with some kind of reducing agent, and in presence of some solvent. So we have to take any starting material and mix it with the solvent, and we add some kind of reducing agent, so that they do some there happens some kind of chemical reactions, and there is a reduction in size of the particle. So that is the basics all about chemical reaction. But how why do we classify is that what kind of external force that we add to the reaction environment, so that categorize the methods basically. So solvothermal reaction is a simple reaction where we don't apply any kind of external reactions, external parameters. So we take the precursors, or we take the in a solvent, and then we mix it with some reducing agent, and then we stir it and we get the nanoparticle. It's very simple process. Whereas in other things like hydrothermal reactions, microwave, and salt gel, chemical greens, and this all, like we apply some kind of external parameters. Either it can be pressure, or it can be a temperature, or it can be microwaves, or it can be a sonar waves, or it can be like a simple biological medium that is available in our environment, all that things. Okay, so we'll see one by one. So before we go for the actual discussions on this chemical synthesis or the bottom-up approaches, there is a term called Ostwald ripening. So I have put over here. You can see. You just consider all these as a smaller sized nanoparticles. So you have one bigger nanoparticle, and surrounded which you have like 4-5 smaller nanoparticles. So what does this Ostwald ripening says is that, so what happens is that at some reactions, when it prolonged, or when we apply some kind of external forces, so all these smaller nanoparticles will go and attach to the bigger nanoparticle. So which means that, like, wherever you have the smaller particles, they go and attach to a single, the bigger nanoparticle, and then it starts growing basically. So this is the basic behind Ostwald ripening. In simpler ways, we can say that the smaller particle grow over the bigger particle. This is a concept. And why does it happen is that whenever you have any nano system which is in less than like 10 or 5 nanometer in size, the process of aggregation is more basically, because the surface energy will be higher, and because of that they cannot be separated. So they'll try to attract each other, and then they start growing basically. So that is the reason why this Ostwald ripening takes place. So in any chemical reactions or any chemical methods, whatever we try to do, so we should always minimize the effect of this Ostwald ripening, because we do some reactions and we minimize the size of the nanoparticle. But once the size is minimized, the surface energy will be more. So they will try to attract each other. Again, they will start to grow it as a bigger one. So this is a drawback of chemical reactions. So we always need to have some kind of chemicals or some kind of reagent or agent which minimize this agglomeration or aggregation concept. So this is one drawback of chemical methods, but we should always take some kind of measures to control that. So either it can be of physical aggregation or agglomeration and all that thing. So the Ostwald ripening is the greatest enemy for any chemical reactions. But by doing some kind of optimization, and by adding some chemicals or reagent, we can control that. So that is the most important criteria we should consider if we work on these chemical methods. So other things are basic and we don't have much important on that. So second consideration is that, so we should consider these three factors. So one, we have these chemical factors, and second is our physical factors, and three is kinetic factors. Okay. So first factor is our Ostwald ripening. Control of aggregation or agglomeration is the main task. And second thing is that we should focus on these three parameters, like chemical factors, physical factors, or the kinetic factors. So chemical factor is nothing but what kind of solvent we use for the entire reactions. Either it can be a water, or it can be any alcohol, or it's up to us. So what kind of solvent we use and the nature of the solvent we use. So that is the one thing. And second thing is that physical factors. So we do some reactions in the presence of temperature or in the presence of pressure, and we apply some kind of stirring speed as well. So these three things should be properly controlled or during the reaction aspects. And third thing is that growth kinetics. Growth kinetics can be greatly controlled once you have control over this chemical and physical parameter. And physical parameter, we can greatly control the basic biomedical engineering. It works with civil engineering, it works with EEE, it works with ECE, it works with energy systems. Like it's a kind of interdisciplinary science or technology, we can say. So everywhere people work on all aspects of nanotechnology. So the thing is that it has certain interesting or fascinating property. That's why people go for nanotechnology. That's a particular thing. So that is what I put over here. Like it travels all along the roads of every science and technology. That is as initial stage of nano, and that's why people are more interested to work on nano. So to precise what is nanotechnology is that it's creating an atom or a molecule or creating an object in the scale of 10 power minus 9. So that is the basic aspect. So creation of 10 power minus 9 is not that easy task. So it needs several optimization, it needs several process, and it needs several hooks basically. So but once you have such systems where the size of the particle is reduced into 10 power minus 9, so there emerges the fascinating properties. That's why people work on creating such systems and make use for their applications. So once you have particles at that dimension, so whatever you see in the normal scale, that will be completely different. Whatever you see in the scale at 10 power minus 9. So that bulk and nano differentiation in the properties that helps us to bring more fascinating thing to work with us actually. So in other ways, like once you have such systems, uh, the efficiency or the output what we get in our bulk scale will be totally different. That's why like people are really moving towards creation of nano objects and make it use for their applications. So even like there are certain products that is being commercialized, which we'll see like which I have also put in the slides. So it's again like it creates a global demand and people start working on the creation of such objects and make use of it for their own applications. Not only limited to one thing, but it's a kind of interdisciplinary one. So that's why people go for creation of such thing and they work on it. Right. So why this basically it becomes such interesting or it's such fascinating is that the one basic property is that it's surface to volume ratio, right? So we do cooking in our home. The simple representation I put here. So if you take a complete potato or any vegetables and we boil it, so it may take some time to boil. But rather doing that, if you cut them into small pieces and you put it and then you boil it, it will boil in a faster manner. So this is a simple way we can think because so if you have any bulk system, you consider this as a yeah. Okay, you can consider the first block as a so you can consider this one block as a complete tomato, potato, or something what I put over here. So if you see this cubical block, the surfaces that is getting exposed to the external environment is only like 1, 2, 3. Back side you have one, and bottom you have one, other side you have one. It's very limited. Like you will have only five faces that is getting exposed to the external factors. But once if you make these cubes into a you deconstruct them and make it into a number of cubes. You have each cubes will have like 5 to 6 surfaces that is being exposed, and you have like 4 cubes. If you again reconstruct that 4 cubes into one again 4 more cubes, again you will have different surfaces. I mean, n number of surfaces you will have. So the surfaces that is getting exposed to the external environment is a factor that gives that fascinating property. So that we call it as surface to volume ratio. So when you have as a bulk, the surface that is getting exposed to external properties will be very limited. But you make it as a nano level, and then you have the surfaces. I mean, you have n number of surfaces, and the exposure will be like more. So that is the one thing when you compare to bulk and nano, you have these exceptional properties. So second property is that we call it as a quantum confinement. So quantum confinement is that it deals with the dimensionality aspect. where you have a particle and where you have this three dimension x, y, z, and if you confine any one direction of that movement, so that we call it as a quantum confinement. So that's what I put over here. So it's very difficult to control in any one direction, because only if you have nanostructures which is sort of less than 5 nanometer in size, should be very less than 5 nanometer in size, only then this quantum confinement can be experienced. So we have to design a system, or we have to create a system such that you have their dimensionality, this quantum confinement place. So once you have such kind of system, we can play with the movement of electron, where we can confine the movement of an electron, how we prepare nanoparticles and how we take up an application. So it will be kind of a mixed up sharing knowledge on physics, chemistry, and electronics parts. So without that, we cannot discuss the actual essence. So but that is my prerequisite. So title is that like nanomaterial synthesis and its application. So maximum focus I would put here on preparation of nanomaterial, how different approaches can be used to prepare a nanomaterial, and positively how it can be taken for several applications with certain focus on sensors, on unflexible electronics, which we will discuss at the end of the slide. And as people have introduced me, ma'am have introduced me, so I don't want to go beyond that. So, talking about the nanotechnology, it's not a single domain where it dominates the